Hello class. Today we are going to start Unit 3, which is on simplifying rational expressions. So when you are simplifying a rational expression, I want you to think of the word ratio inside of rational, which ratio is just another word for fraction. So we are going to be dealing with fractions today, but they're not just going to be number fractions. So a rational expression is going to be a fraction that has a polynomial in the top and in the bottom, which means that it is going to have x's in it. So it's not just going to be numbers, we're going to be dealing with variables as well. So the simplified form of a rational expression, again, is going to be a polynomial over a polynomial. And we're going to be practicing simplifying them or reducing them, similar to how you would simplify or reduce a numerical fraction. So if you think back to when you first learned about number fractions, you would try and reduce them to the smallest possible fraction. Kind of a similar idea today, except we are going to be having to factor in order to do this. So your numerator and denominator, we want them to not have any common factor in them in order to be fully simplified. So to simplify it, we're just going to be factoring and then dividing out or canceling any common factors from the numerator and denominator. But just like with a number fraction, we are not allowed to divide by 0 ever in math. So we need to look and see when will that denominator be 0. So we look and find what we call excluded values. And these excluded values are going to be numbers that if we plugged them into the fraction would make us divide by 0, which we're not allowed to do. So we want to try and find that. So we're going to start off with some easier problems today. Remember, polynomials can have one term where you just have a number and a variable, but you can also have binomials or trinomials. So on this first one, we have a monomial with 21a squared divided by 7a cubed. And I like to do the numbers first. So let's look at the 21 and the 7 and reduce that. So we know 7 goes into both, right? So 21, if I divide it by 7, is going to be 3, and 7 divided by 7 is 1. So we don't really need the 1, but I'll just write it for now. And then let's look at the a's. We have a squared over a cubed. And if you remember back to when you learned your exponent properties, whenever you have the same base being divided, the trick is to subtract the exponents. So if I do 2 subtract 3, I get -1. So I would have a to the power of -1. But we also don't like having negative exponents. So whenever you have a negative exponent, to turn it to a positive exponent, you take that base and you move it down to the denominator. So we're going to take that a and move it down to the denominator, and then it would turn to a +1 for the exponent. But the 3 is not attached to it, so it will stay up in the numerator. Another way you can think about it is a squared is a times a, and a cubed is a times a times a. So you can cancel out 2 of the a's, which leaves 1 a left in the bottom. So that's kind of a visual way of seeing why you have an a down in the denominator. But our answer there it would be 3 over a. And then we do want to look at our excluded values. So we want to know what would make that denominator equal 0. And so the only number, whenever you have a monomial, it's kind of easy. The only thing that will make it 0 is if a is 0, since that's really the only thing in the denominator. So, but we would want to say a can't equal 0. So when you do your little equal sign, you're going to put the little slash through it to say a cannot equal 0. And that would be considered your excluded value, so we can't divide by 0 with it. So you have your simplified fraction and then your excluded value, so kind of 2 answers to this question. Hey, on the next one, we have a monomial and then a binomial in the bottom with 2 terms. So when you start getting more terms, like all of these have binomials in them, what you're going to be doing is you still want to think of finding your common factors whenever you have these bigger polynomials. So in order to simplify them, you're going to look for common things. So when you have binomials and trinomials, a mistake I see students make a lot is they try to just cancel out part of the binomial and not all of it, but you need to think of it as a whole group. So that 4D plus 8 is a group. I can only cancel something if it goes into all of the parts. So I can't just like cancel the D's from the top because there's not a D on the 8. So what we could do though is if I look at the 18, the 4, and the 8, they are all even, so they do all have a common factor of 2. So we'll want to pull a 2 out of the top and a 2 out of the bottom. So I'm going to write it as 2 times 9, d squared. And then for the denominator, think of that 2 as being a greatest common factor. So we're going to write the 2 out front, which if I take a 2 out leaves me with 2d and then plus 4. But now we have a 2 in the top and a 2 in the bottom. So those 2's are going to cancel, and we are left with 9d squared over 2d plus 4. So again, here's where I see students make mistakes. They try and cancel those d's, but remember that 2d plus 4 is a group. It's kind of all or nothing. Unless I can take something out of all of the parts, I can't cancel it. So we can't take that d from the top and cancel it with a d in the bottom. So we're essentially just done now. Our answer will just be 9d squared over 2d plus 4. So just remember, you can't cancel just one term from the binomial. It has to be all or nothing, so don't make that mistake. If it helps to write parentheses around it, go ahead and do that so that you remember it's a group and you can't separate it. Okay, looking at this next one, we have another binomial over a binomial, so 2n minus 3 over 6n minus 9. Again, we cannot just cancel those n's from the top to the bottom. Think of them as a group. So that 2n minus 3 is a group. I can't cancel it unless I can cancel the entire thing. So I like to always try and find a greatest common factor first, but for 2n and 3, there's not a common factor. 2 and 3 are both prime. So we're just kind of stuck. We can't take anything out. So 2n minus 3 will just stay the same. But then on the denominator, 6n minus 9, we do have a greatest common factor. For 6 and 9, we can take a 3 out of both. So if I take a 3 out, 6n divided by 3 is 2n, and negative 9 divided by 3 is negative 3. But if you look at the top now, we have a 2n minus 3 in the top and a 2n minus 3 in the bottom. So that's what I'm talking about with the group. We can only cancel it if the entire group can go. So now that those two groups match, we can go ahead and cancel the 2n minus 3. But what would be left over in the top? We know there's a 3 down in the bottom, but if I cancel everything in the top, what's left over? And I see students make this mistake a lot. It's not like it just disappeared. It's not a 0. There's really a 1 written there. We usually just don't write the 1 because we're lazy. So when we cancel everything from the top, don't forget there's really a 1 still there. So our answer is 1/3. Okay, let's look at part D. We have another binomial on the top divided by a binomial on the bottom. So 26c cubed plus 91c divided by 2c squared plus 7. So again, I always start with just the numerator, trying to take out a greatest common factor. So for 26 and 91, the greatest common factor for that is actually going to be 13. And then we also have some c's we can take out since each term has at least one c, so we can take out a c from each. So our greatest common factor is 13c. So taking that out, 26c cubed divided by 13c is going to be 2c squared. And then 91c divided by 13c is going to be 7, and the c's just cancel. So we just get the 7 back. And then now, looking at the bottom, there's not a common factor. 2 and 7 are prime, and we just have a 2c squared plus 7. But that works because when we factored the top, that's what we got as well. So now we have matching groups. We have a 2c squared plus 7 on the top and the bottom, so we can cancel them. And so we are left with a 1 on the bottom, so we would have 13c divided by 1. But anything divided by 1 is just itself, so our answer is just 13c. And I just realized I forgot to do the excluded values on B, C, and D. So let's go back to part B and do the excluded value. So again, you're going to take that denominator and set it equal to 0. Because we want to know what number is going to make that denominator equal 0, because that's a bad thing. So first subtract the 4 over and then divide by 2, and you get -4 divided by 2 is -2. So what that's saying is if I plug -2 into my original problem, we're going to divide by 0, which is not allowed. So we're going to say D cannot equal -2. So put that little slash through it. And then same with C. We're just going to go off of the original denominator, the 6n minus 9, because if you notice on this one, the n's canceled out in our answer, but we still had them to start with, so we still need to check and see when we would have a problem with n being 0. So set the original 6n minus 9 equal to 0, and then start solving from there. So we're just taking that original and we're going to add the 9 over, and we have 6n equal to 9, and then we're going to divide by 6. And then if we reduce, we have 9 over 6, which will reduce to 3 halves if we divide each of those numbers by 3. So 9 divided by 3 is 3, 6 divided by 3 is 2, and so n cannot equal 3 halves. If we plug 3 halves in to our original problem, we would divide by 0. Again, we're not allowed to do that, so we're finding that excluded value. And then on part D, we have that original 2c squared plus 7 in the denominator. So we're going to take that original denominator and set it equal to 0, and then subtract 7 to start solving. So we get 2c squared equals -7, and then divide by 2. So we get c squared equals a -7 halves. And here's where we run into a problem, because if I want to get rid of that square by square rooting, we end up square rooting a negative, which we're not allowed to do either. So really this would end up being an imaginary answer, because whenever we square root a negative number, you get those little i's in them. So the answer to that, whenever you get a negative in there, you would just take that negative out and you would keep the square root of 7 halves, but instead of the negative, you're going to put the little curvy I on the outside. So that would be technically your true excluded value, but you won't see very many of those, so don't worry too much about a problem like that. You're not going to really get any of those. That's just kind of for an example. Okay, let's look at some that have trinomials in them, because with trinomials, we do factor them a little bit differently. If you do have a greatest common factor, you want to take it out, but a lot of times you'll be doing like factor by grouping or something similar. So you're still going to approach it the same way we did all these other ones, where you want to try and factor the top and bottom. So if I look at the numerator on this one, we have a 2x minus 8, and then on our denominator an x squared minus 2x minus 8. Again, a mistake I see a lot is students just want to cross out those 2x's and cross out those 8's. You're not allowed to do that. Again, think of the top as being a group and the bottom as being a group. We can't just cancel going down. So instead, take out your greatest common factor, which on the top is a 2. So if I take a 2 out, I get 2 times x minus 4. And then on the denominator, we just have an easy trinomial here. Think what multiplies to be -8, but adds to be -2. And I like to do these little x tables where I put the last number on the top, so -8, and then the middle number -2 on the bottom of the x. And I think what multiplies to be -8, but adds to be -2. And so thinking of our factors of -8, we could do 1 and 8, but that's not going to work. The other option is 2 and 4. But I do need to somehow get my signs so that when I add 2 and 4 together, it adds to -2. And so we want that 4 to be negative, so that 2 minus 4 is -2. So we take those two numbers, 2 and -4, and we plug them into our binomial so that we get x plus 2 and then x minus 4. And you'll see now we have matching groups. Again, that's the only way you can cancel a group, is if the entire group matches. So we have that x minus 4 on the top and the x minus 4 on the bottom, and we can go ahead and cancel those now. And so that leaves us in the numerator, we're left with a 2. And then on the denominator, an x plus 2. And again, another mistake I would see is students just want to cross those 2's out. We're not allowed to do that. It's all or nothing with that group on the bottom. So that binomial it has to stay a binomial. I can only cancel it if I have an x plus 2 on the top, which I don't have. I only have a 2. So just don't fall into that mistake that I see students make all the time. Again, if writing parentheses helps you to remember that that's a group, go ahead and do that so that you don't forget. But we also need to do our excluded values, and with a trinomial, whenever you want to know when a trinomial is equal to 0, you go based off of the factored form, which lucky for us, we already factored, so we don't need to do more work. So you're going to take each of those factors, the x plus 2 and the x plus 4, or minus 4, and set them equal to 0, and then just solve. So on the first one, you'll minus that 2 over. On the second one, you'll add that 4 over. And those are going to be your excluded values. So if I plug negative 2 into my original problem, negative 2 plus 2 is 0, so that's a problem. If I plug 4 in, 4 minus 4 is 0, that's a problem. So x cannot equal negative 2 or 4. And those are your excluded values so that we do not divide by 0. So you have your simplified form and then you have your excluded values. So again, kind of two parts for your answers on these questions. Okay, let's look at another one. So on this one, we have a trinomial in the top. We have a squared minus 3a plus 2. So if we factor that, we want to think what multiplies to be 2 and adds to be negative 3. So easy factors for 2 are just 1 and 2, but we need them to make a negative 3. So we're going to add a negative on both of them this time. And when we times those two negatives, it turns to a positive 2, but they add to be that negative 3. So we'll plug in the minus 1 into a minus 1, and we'll plug in the a minus 2. And then looking at the denominator, let's factor that. We added a 3a minus 3. So when we have a binomial, you just want to take out the greatest common factor, which in this case is a 3. We can take that out. So write the 3 out on the front, and then 3a divided by 3 is a, and negative 3 divided by 3 is negative 1. And we have those matching groups that we're hoping for, so the a minus 1's cancel, and we're left in the top with an a minus 2. And then in the bottom, we're left with a 3. And that would be your simplified form. And then again, to get your excluded values, you're just going to go off of the denominator. So take that 3a minus 3 from the original denominator and set it equal to 0. First, add the 3 over to solve, so that you get 3a equals 3. And then divide by 3, and 3 divided by 3 is 1. So a, again, cannot equal 1. If it did equal 1, we would divide by 0, which is no bueno. So a cannot equal 1. That would be your excluded value. Okay, let's look at some more. On this part C, we have a binomial and then a trinomial on the bottom. So if we factor that top part, 6z plus 12, the greatest common factor would be a 6. So taking the 6 out, we're left with 1z plus 2. But then in the bottom, we do have one of those trickier trinomials. We have that number in front of the z squared. So in order to solve this, we do need to do the factor by grouping. So I'm going to come and do this to the side, but first you start by taking that first number 2 and timesing it to the last number 6. So 2 times 6 is 12. And then with that number, we think what multiplies to be 12 but adds to be 7. So if we think of our factors of 12, 3 times 4 is 12, but then 3 plus 4 is 7. So we're going to use those two numbers. And again, with factor by grouping, you're going to rewrite that middle term so that instead of having 7z, we're going to write it as 3z and 4z. So keep the first part, the 2z squared, and they always use 2's and z's together, so I always put the little lines in the z's so that I can tell if it's a 2 or a z. And then also keep the 6 in the back. So now we have 4 terms, which lets us do 2 groups of 2 for our factor by grouping. And now in each group, you're just going to take the common factor out. So for 2z squared and 3z, oops, there's a plus, that's supposed to be there. The only common thing are the z's, so we can take 1z away from each term, which leaves us with 2z plus 3. And then in our second group, for 4z plus 6, the greatest common factor is a 2. So 4z divided by 2 is 2z, and then 6 divided by 2 is 3. And again, with factor by grouping, those groups should match. That's kind of your checkpoint. If these don't match, that means you did something wrong, so you want to go back and look and fix it. But mine matched, so I'm good. So now to write my answer for my factorization, you keep one of the matching parts, so one of the 2z plus 3's, and then those common factors out front are going to go into their own group. So you'll have a z plus 2. So that would be our factored form of that trinomial. So I'm going to go and replace that denominator with the factored form. So I'm going to write the 2z plus 3 times z plus 2 on that bottom. And now we can see the z plus 2's cancel with each other. Those are the common factors in the top and bottom. So we're left with a 6 on the top and then 2z plus 3 on the bottom. Again, just be careful that you don't try and cancel like the 6 and the 2 or the 6 and the 3. If we were to take a number out, it would have to be between all three numbers, which unfortunately we can't do. So we're just done. So again, think of that 2z plus 3 as a group. It has to kind of be all or nothing. So that would be our simplified form on that one. And then for your excluded values, again, you would just take the factored part of that trinomial, the 2z plus 3 and the z plus 2, and set them equal to 0. I'm just going to do it in my head just because we're kind of running late on time. So for 2z plus 3, if I solve, I would end up with a negative 3/2. So z cannot equal negative 3/2. And then for z plus 2, the shortcut would be to just flip that sign. So z cannot equal negative 2. So those would be your two excluded values, negative 3/2 and negative 2. So just remember, you always just go off of that denominator. And if it's a trinomial, go off the factored part. We're running out of time, so I'm not going to do D. If you want to, you can do it on your own. But we're going to move down to the next section, which is what we call opposite factors. So opposite factors happen. Let me zoom in a little bit so you can see a little clearer. When the top and the bottom are almost the same, but not quite. So if we look at this numerator, we have x minus 3. X is positive, 3 is negative. On the bottom, we have 3 minus x. So the signs have flipped. Negative 3 on the top, positive 3 on the bottom, positive x on top, negative x on the bottom. So the only difference between those two parts are the signs. So whenever you run into opposites like this, what you're going to end up doing to try and get them to match is you're going to factor out a negative 1. So like on this problem, if I factor negative 1 from 3 minus x, it's just going to flip those signs so that that 3 turns into a negative 3 and the negative x turns into a positive x. But when we do that, it's going to allow us to cancel those groups out. So like on this one, we see that the two x's, one's positive, one's negative. We have a negative 5 and a positive 5. So we're going to factor a negative 1 out, and you only need to do it from one group. It doesn't really matter. So I'm going to take it from the bottom. So when I take a negative 1 away from that 5, it turns to a negative 5. And with the negative 2x, when I take a negative away, it turns to a positive 2x. So we're just switching those signs from negative to positive and vice versa. And now you'll see the groups match. They're written backwards from one another, but they both have a positive 2x and they both have a negative 5. So we don't really, if you want to, you can rewrite them, but we can just go ahead and cancel them now. But remember that top, when everything cancels from it, there's like a 1 in the front. So it's really like we have 1 divided by negative 1, which if we simplify is just negative 1. This case was a little bit more obvious where you can see right away that they're opposites. On other ones, you'll notice that doesn't happen. So I'll show you another one here in a second. But for your excluded values, I know it gets kind of annoying to do these. Still just take that denominator and set it equal to 0. So we add the 2x over, and then we want to divide by 2, and we get x cannot equal 5/2 for our excluded value. So again, that one's kind of a more obvious problem where just right away they look like opposites, but most of the time your problems aren't going to be that easy or straightforward. You're going to have ones like the rest of these, like B, C, and D, where looking at them originally, you might not be able to tell that there's going to have opposite factors in the problem, but as you get going, you'll run into it. So I'm just going to do one more just for the sake of time. But looking at 3 minus 9d, and then we have our trinomial. So far, I can't tell they have opposites, so I'm just going to approach it the same way I normally would and try and take out a greatest common factor from that top. So take a 3 out, which leaves us with 1 minus 3d. And then in that denominator, we have another trinomial that has the number in front, so we do need to do our factor by grouping. So I'm going to take that first number 6 and times it to be to -1, and then think what multiplies to be -6 and adds to be 1. And so our factors for that would be 3 and 2, but we do want to get our signs right. So we're going to do a +3 and a -2. Oh, sorry, you guys can't even see what I'm doing. And then we're going to rewrite that middle term. So instead of having the plus d, we're going to write plus 3d and then minus a 2d instead, and then keep that -1 in the back. That way we have 4 terms instead of 3, and now we can do our 2 groups of 2. And then once you have your 2 groups of 2, you're going to take the common factor out of each. So for 6d squared and 3d, we can take a 3 out of both of the numbers and a d out. So 6d squared divided by 3d is 2d, and 3d divided by 3d is 1. And here's another place I see students make a mistake a lot. If you end up taking out something all the way, it doesn't just disappear. So like if I do 3d and I take out a 3d, there should still be a 1 there. I can't just put like a 0 or have it disappear. So just kind of think about 3d divided by 3d is 1. Anything divided by itself is 1. So you should always have that 1 placeholder there, and that's a really common mistake that I see students make. So if you start with 2 terms, you should always end with 2 terms inside the parentheses. But let's take out the common factor of the other group. So for -2d and -1, again, I'm trying to make those groups match. Right now, one's negative and one's positive. So we're just going to take a -1 out to make the signs match. So the -2d and the 1 both turn to a +2d plus 1. And now my 2 groups match, so I'm good. So my answer, I take one of the matching groups, the 2d plus 1. And then those common factors out front go into their own group. So we get a 3d minus 1. And that's going to be our factored form that we replace into the denominator instead of our initial trinomial. So I'm going to write down the 2d plus 1 times 3d minus 1 down on the bottom. And now when we're trying to cancel, you can see things don't exactly match. We have our opposite factors that we were talking about. So I have a 1 minus 3d and then I have a 3d minus 1. So they're almost the same except the signs are backwards. So here's where we would want to take out a negative. Again, you could take it out from either, but since we took a 3 out already, I'm going to take out a -3. And if I take that negative out, it just makes that 1 turn to a -1, and then that 3d will turn to a +3d. So now the top and the bottom match. I have a +3d and a -1 in each group. So I can go ahead and cancel those. So my answer, I would have that -3 in the numerator and then the 2d plus 1 in the denominator. And that's my simplified form. And then for excluded values, again, you would just go and take each of those factored parts in the denominator and set them equal to 1. I'm just going to do it in my head again, just to save some time. So we would get d cannot equal -1/2 for the first group. And then for the 3d minus 1, we would add the 1 over and divide by 3. So we would get a 1/3. So those would be your excluded values. So if you want, you can go and do some more on your own with the B and part D, but this video is already getting pretty long. So I think we're going to go ahead and stop there. We have some story problems. I think we will save these for later. We're going to get to more story problems in the future, and this video is already getting pretty long. So we'll just save those for later. But let me know if you guys have any questions. I am here to help. Just email me. We can set up a Zoom meeting. This is kind of a trickier unit, so if you're having a hard time, let me know now rather than later, and we want to try and stay caught up on it. But I hope you guys have a good day, and I will talk to you later.